Hello there everyone, and very welcome to this third lecture in our course about Java programming and data structures. And the topic for today will be programming graphical user interfaces using JavaFX, which is the way of programming graphical user interfaces today in Java. And we have an agenda today where we will begin with trying to find out how we got here. So, discussing first and foremost graphical programming in computers from day one, basically, and how it has evolved over time. And then moving on to how we've done it in Java, because this is actually the third attempt at creating a good, solid way of creating graphical user interfaces in Java. So we'll have a short discussion on the previous attempts as well before we dive into exactly what JavaFX is. And the last part of this lecture will be just that, giving you a short introduction on exactly how to program your graphical user interfaces using Java or JavaFX. So a simple hello world, a short look at different effects that we can put onto a JavaFX user interface. We will draw some shapes, and most important perhaps, to respond to actions in different ways. And for those of you who have already downloaded the slides, I'd like to say that I have shifted around the slides at the end a little bit to make it clearer exactly what's happening. We will end it all with talk about layout and layouting in JavaFX, how to put your components or graphical visual components onto the screen in the best possible way. Lastly, after the last part, we will have a few slides where I discuss where you can find out more information. You will of course get more information in the next lecture, which will be we will go through a lot of the different components, visual components that are available in JavaFX. But before we can do that, we need this solid foundation to understand how it actually works. So that's the basic idea of how we are going to approach JavaFX. And the first part, as I promised, is to look at graphical user interfaces as such. And they've been around for a long time. Most of you know that the first computers and computers for a long time have used text in order to communicate with the user and the user to communicate back to the computer. But it really has been the natural way to use graphical user interfaces or GUIs since the 80s. And since it's been around for such a long time, there have also been a large number of different graphical user interfaces since then. We have all the Windows stuff with the old stuff like Windows 3.x something. We have Windows 95, Windows 8 and now Windows 10 with little tweaks on especially the way the different components look. On Mac OS we have a different set. We have basically the same things like buttons and windows and text boxes and whatnot, but they look slightly different. And lastly, we have the nice world, the Unix world, the Linux world, where we have GTK+, Qt with KDE and so on. All of these looking slightly different and also programmed in a different way. Most of the work on basically creating what we today know as graphical user interfaces was done at Xerox PARC in the 70s. You know, that place in the States where they had extremely many good, bright ideas like the graphical user interface, like object orientation, like Ethernet and so on, laser printers. The problem was that they didn't commercialize their stuff, so other people, other companies did that instead. But at this place they coined and they used what's called today WIMP, Windows Icon Menus and Pointers, and that's the foundation of graphical user interfaces even today. What has happened on the other hand is that we have evolved these concepts and we've added minor tweaks and minor different ways of doing this, especially since the introduction of smartphones, in order to make it easier to work with many different displays. In the beginning, and we are talking Windows 3, the motif time and so on, so in the 70s, 80s and even earlier, there were no direct connections between the programming language that we used and the GUI that we used in order to display things on the screen. In these days, most of the stuff was written in C, and you could call these C libraries from a great many different programming languages. Like, for example, Pascal. You could create a nice-looking graphical user interface using the programming language Pascal, but you had to have bindings for the C library, so you call these bindings that call the library that displayed stuff on the screen. This was not very easy. It was rather difficult to get things to be good. It was extremely difficult to get these graphical parts to be incorporated in your programming language in a nice way. And in those days, most programming languages weren't object-oriented either. And as we'll see later on in this lecture, it actually helps if the programming language is object-oriented. Just to show you something, here's some code for displaying a window in Windows using Win32 library, and this is written in C, and there's loads of stuff that I have absolutely no idea of what they're actually doing. They are creating a callback for the Windows procedure itself, and then we have some sort of Windows main where we create some sort of window and it goes on. We give some icons, cursor stuff, register all of this into the underlying mechanism that really makes this work, and then we have the HWND create window X, which is actually the window itself, giving it a name, some default location, I think, and loads of error handling stuff won't show, and then a loop which merely puts it up on the screen and you can see the window saying actually nothing. It's merely a window. In this course we are going to have 2 lectures in programming graphical user interfaces. If programming user interfaces would have been anything like it was in these Windows days, in the old Windows days I should say, then we would have needed far more than 2 lectures in order to get anything up on the screen. So hooray for Java and JavaFX. But Java and JavaFX aren't the first real ways, of doing this. We've had a number of programming languages which try to incorporate visual programming or rather the ability to create nice looking graphical user interfaces. And one of the first ones was Smalltalk. It was created in the 70s but popularized during the 80s and slightly into the 90s as well. If you have nothing to do, just check up Smalltalk, because it's one heck of a language. And everything feels rather strange. Some people would die for this language, so it's quite interesting, really. For one thing, the environment, the development environment is the thing that you are modifying in order to create programs. Smalltalk is also extremely object-oriented. You can't do anything in any other way than object-oriented. Interesting, look it up, and then be happy again for Java. Yay! Other languages, Visual Basic. You probably heard about Visual Basic, which was Microsoft's first attempt at creating a easy-to-create graphical user interface builder with a programming language attached. It has a rather... people know of it, and it's widely used. There's really just one or two problems with it. The first one being that it is basic, and basic isn't that very much fun. So therefore, it hasn't been seen as a real contender for anything, really. Though they have a rather large market share anyway. And the second one being, of course, that it is Microsoft, so it's only running on Windows. This is Squeak, which is a modern variant of Smalltalk, where you can just see the system browser for a button where you can add the stuff that's going to happen with whenever you push this button. And I've actually programmed some Smalltalk, but I don't really remember now what this one is doing. But as I said, it's an interesting concept, and it made it fairly easy to create graphical user interfaces in the way that we want to do it, namely incorporate it into the language itself. But enough of that history right now. Let's look at what we are able to do today. And again, the thing is that we have a number of pieces or number of ways of doing this, of creating graphical user interfaces. Some of them are highly integrated, like Visual Studio, where you have a simple drag and drop builder for the .NET language, for example C# and Visual Basic .NET and so on. We have others like C++ Builder, which basically does the same, but it's using the C++ language instead. Qt Creator for C++, Gambas, which is a basic variation, and so on. And where does Java fit in all of this? Well, Java has and has always had a standardized way of creating graphical user interfaces. They have not adopted the Microsoft way of dragging and dropping components onto a window and then working from there. They've always worked from the ground up with code, and in the code you create the graphical user interface. This, however, is changing slightly, at least, with JavaFX. So let's just take a few moments now to talk about graphical user interfaces in Java, because that is what we are interested in this course. The Java language, as you know by now, was introduced in '95, and even then it had this write once, run everywhere slogan, which meant also for graphical programs. So the idea was that you could write a graphical Java program with a nice graphical user interface and so on, and without recompiling it, you could run it on a Solaris machine or a Windows machine or a Macintosh machine, and so on. It didn't always work, but most often it works quite okay, at least. And Even though 95 really doesn't feel that old as compared to C++ or C language or any of the really old languages, they've been able to construct 3 different approaches to to create graphical user interfaces. So 3 different ways, and they are quite different in their approaches. They are called the Abstract Window Toolkit, or AWT. After that came Swing, and today we have JavaFX. And we'll look slightly, at least, onto all of these just to give you an idea of what it looks like and how it works, so that you know how much better actually JavaFX is than the previous 2 attempts. And I'll try to explain that as we go along. At the same time that they released Java, they also released the Abstract Window Toolkit. And it worked like a thin wrapper around the operating system that you used. That meant that it used the components that were available in this specific operating system that you were running. So if you ran a Java program on a Windows machine, you would have a Windows button, for example. If you ran the same program on a Mac machine, you would have a Mac button there instead. So it merely said to the operating system, let's take this button and place it there. A thin wrapper around it, and this is called a heavyweight component. The good thing about this is that you get the exact same looks as anything else on the platform. As the button looks exactly and is a Windows button in a Windows program in Java, well, it looks exactly the same as all the other programs that you might have running on your computer. The problem was that all of these different elements or components behave differently, look differently on the different platforms, and thereby taking up different amount of space on the screen, reacting differently when used, and so on. So this made it rather difficult to create a program that actually worked as well on a Windows machine as on a Solaris machine or a Mac machine, and so on. They work differently because the components in the operating system behave differently and look differently. This also meant that as soon as the operating system provider, Microsoft or Apple or Sun or whomever it might be, changed something, then Java had to re-implement parts of how AWT worked. Because if you change the way a button works in Windows and the Java program is using that exact button, then you need to change also the programming behind the Java button. So this made it very vulnerable for changes in the underlying operating system, also meaning that at this time Sun Microsystems, the creator and at that time developers of Java, had to put a lot of resources into trying to keep up with the changes in different operating systems. And here's a short example of what AWT could look like. You see the image, and I ran this on my computer, which is running GNOME 3 on a Linux machine. So therefore, it looks slightly like a GNOME 3 program with the button, even though you really can't see that, but the button looks like a GNOME button, and everything looks slightly like that. The code itself, as you see, begins by creating a frame and then a button, and then putting these things into a really places onto the frame and with set visible to true, and everything is shown in this window. So all these different components are different classes that don't really belong to each other, but they are placed upon each other. And we'll talk more about that when we get to JavaFX. With Java 1.2, or as they called it, Java 2, from the end of '98, they instead included what's called Swing. And in Swing, they change the way they look on the different components in the graphical user interface. And they go from being a heavyweight to a lightweight approach instead. This means that instead of relying upon the operating system to provide buttons and drop-down lists and whatnot, they do it themselves. They create, using Java's own drawing mechanisms, different buttons and list boxes and all the other different things. So only a very minor, a very small part of Swing is actually depending upon the operating system, and only those small parts that talk directly to the operating system on how to draw something simple on the screen. And instead of saying, get me a button, it says, draw like this, and Swing says, well, this is a button. This, however, means that the look and feel of a Swing application does not really have to look anything like anything else on that platform. And that's because in Swing, as it is lightweight, they have to create something, a look, they call it pluggable look and feel, for this specific application. There were a number of these look and feels included directly into Java at this time. The standard one called Metal, and then you can change between them. The good thing with that is, of course, that when you create the Java program, it will look exactly the same when it's running on Linux, or when it is running on Windows, or when it's running on a Mac. It will look and behave exactly the same because Java is in charge of exactly what it looks like. But that's also the problem. Most of you, I guess, have the feeling that you recognize a Java program or a program that's coded with Java and Swing because it doesn't look anything like anything else on your computer. It can look extremely ugly, really, if you use the default looks. There are a great many pluggable look and feels that makes this better, but in the end, you can often see that, well, this is a Java program. They wanted everything to be backwards compatible with everything they've done before. So instead of calling things frame, button, text field, and so on, they introduced a J in front of everything to prefix everything. So J frame for creating a window itself, J button for creating a button, and J text field for creating the text. And that's not really good looking, I'd say. However, as they were not depending upon the underlying operating system, they could introduce new elements and introduce them on all the supported platforms. So for example, in this case, the slider that you see on top of this window is not really a standard component in on all platforms, but they could create one because Java was in charge of whatever was on the screen. This is with a Metal look and feel. and it feels rather dated. So I just threw in a Nimbus themed one instead, and you can see in the beginning of this code, just underneath the main, that we use UI manager set look and feel, and we take this Nimbus look and feel instead. And there's a slight difference if you look at the window itself. It has a round button, for example, in the slider, and the button looks a bit more fresh, and so on. Problem here, even though there are different pluggable looks and feels available, there are also companies creating these and selling these. The problem is that there aren't that many nice looking plug and feels. This one, the Nimbus look and feel, looked really nice when it came to us in the early 2000s, something like that. But today it looks dated. And it's quite difficult to create these looks and feels. You need to create quite a lot of different classes that need to interact in different ways and so on. So it's fairly difficult to create something that looks good today with Swing. It's not impossible, but it is more problematic than you would like. So with all of this in mind, we are going to look further into what's real today, namely JavaFX. And JavaFX has actually been around since 2008, but it was something completely different. It wasn't perhaps completely different, but it was very different from what it is today. First and foremost, this was a scripting language. It was meant for the web, really. It's still available, but under the name Visage instead, and not with any support from any large company, really. They made this, should we say, old JavaFX version until 1.3, but during the acquisition of Sun Microsystems, when Oracle bought Sun Microsystems, they saw JavaFX, they stopped development of the scripting language and created something new. And around October 2011, at the Java 1, they announced JavaFX 2.0. When they announced it, they only released a first version running for Windows, and people were asked to actually say what they thought of the language and the way to create graphical user interfaces. And I loved it from day one. Yeah, I actually downloaded the first release. I'm so cool. Yeah. This new version of JavaFX was completely integrated into Java, and this is a big thingy. The previous JavaFX was, as I said, a scripting language which you could use, but here we actually use it with Java. And it's the way in Java today to create graphical user interfaces. And they're so confident on this, Oracle, that they have stopped developing Swing altogether. There's still some support for Swing because most applications today are still created using Swing for Java. But they want everyone to transition as soon as and as fast as possible to JavaFX. And to that effect, they've also included Swing integration into JavaFX, meaning that if you like, you can create your own, you can take your old Swing application and just put it inside of a JavaFX application during the time that you transition more and more of the code to JavaFX. One thing that it does take from the old scripting language is the idea of it being scene-based, and we'll see more about that later. basically meaning that we create a sort of a tree inside in our program where all the different parts actually fit together. And that's quite nice. Also, a nice thing with JavaFX is that it is modern. It tries to utilize the hardware as much as it possibly can. That means, for example, that it is hardware accelerated on most platforms. And that's a good thing. This went very well. So 2.0 of JavaFX in 2011. And 2.0 included in Java 7 update 6 and later, meaning that we had support for all the major platforms like Windows, Mac OS and Linux. So it works on all of them. In 2.2 they also included better support for media, so it plays most videos. It has a canvas control similar to what we can find in HTML5. It has touch controls, and there's plenty of work, not by Oracle, but by many others, to actually use JavaFX as a programming mechanism for all kinds of devices. For example, it's today possible to create a JavaFX application that you can run on iOS and on Android. And on Raspberry Pi, of course. And so on. So it's quite versatile. With the release of Java 8, JavaFX versioning numbers disappeared. So you don't really say JavaFX 8. You see that from time to time. But today, JavaFX is just JavaFX. And from Java 8, it's the primary way. And they introduced a number of improvements in version 8 as well. For example, a new theme called Moderna. That makes us think, is this again lightweight? Yes, it is lightweight. So it does not rely upon the underlying operating system to render the graphics. It uses its own code. The good thing about this is that it is now extremely lot easier to create these themes. And we'll see more about that later on. They've also introduced JavaFX 3D, which makes it possible for us to create 3D graphics, really nice 3D graphics. They have a demo where they show some sort of containers being lifted by cars or trucks rather, and lifted around in a from a boat onto the harbor and so on. Really, really nice, hardware accelerated, so it does work really, really well. Printing, date picker, text flow are new components. From update 40 and so on, they've introduced dialog boxes as well, which was one major omission from the previous versions. Still some small things missing when compared to Swing, but we are getting there. And for those things that are missing, you can almost always find that in the easy to use, easy to add third-party libraries, like for example Controls FX, which is a number of controls created by people who are working at Oracle with JavaFX, but they are not putting this in the real stuff. This is more of a side project for them. But things have actually moved from Controls FX to the real JavaFX as well. When programming, we need to have a IDE that supports JavaFX. And really, if your IDE supports Java 8, it does support JavaFX as well. Sometimes you need to add this some way, like saying, well, I want it to show for JavaFX as well. NetBeans, which is Oracle's own IDE, always has the support for all of this first, and still has had it from almost the beginning. If you instead want to use Eclipse, which is a good choice, I'd say, there's this plugin called EFX Eclipse. Well, it's there, and I think you can click it as well. So, and this adds support for code completion and all other good things that you need in a modern IDE. Just go to the Eclipse Marketplace and install it. There's also some instructions on the web page on how to do it. It works really, really great. Always see too that you have the Java compiler set for Java 1.8. That shouldn't be a problem today, but just make sure. I said in the beginning that there hasn't been a standardized way of dragging and dropping and visually creating graphical user interfaces in Java, because we've always done it by hand. But as time passed, they saw the need for GUI builders, and actually for example for Swing there are a great number of these GUI builders that you could use. That's partially okay, I guess, but for JavaFX, Oracle decided to create one standard tool for building graphical user interfaces, and they call this Scene Builder. However, Oracle no longer supply any binaries for this. They just supply the source code for it, and it's in Java. And it's actually a great example of what you could do with JavaFX as it is programmed using JavaFX. There are a number of ways to test this. The easiest and best way is actually to go to the company Gluon, which supplies this compiled for your specific platform. And they actually just released version 8.1.0 last week, I think. And it looks something like this. It's possible on the left side to see all your controls, and you just drag and drop them onto a window, and then you add a number of properties for it as well. It's good looking. It doesn't work like, for example, in Visual Studio, where you double click on stuff and then you enter code. No? When creating this, they had another idea, namely to have a difference between the development and the design. So what Scene Builder does is to create something called Fxml, which is an XML format which describes exactly how the user interface looks like, what it looks like. And in your Java program, you just import this and you add the code that you need in order to make the behavior. So actions for the buttons and whatever it might be. The idea here being that the designer should work in Scene Builder and design a graphical user interface without knowing any code. Because a really great designer is most often not that good as a programmer, and most really good programmers are really awful designers. So we try to split them apart and let the people that are doing the best things on either side do their things, and then we can combine it using this Fxml. So Scene Builder exports Fxml, and any programming language or any tool could potentially do this. We haven't seen anything else than Scene Builder just yet, but it might arrive. All right, And now the good stuff, namely programming JavaFX after the break. All right then, we're back. But with very little oxygen in the room actually. So please stop breathing if you can. Otherwise, we will continue with programming JavaFX, which is the fun stuff, of course. And as I said previously, we change the metaphor for how we look at our user interface with JavaFX. And they usually say that we have this theater metaphor instead. In a theater we have a stage, and on this stage we can have several scenes, and on this scene we can have different actors. That's how a theater works. You know, these nice theaters where you can actually change the scene itself. And that's actually how JavaFX works as well. We have a stage which is more or less like the window itself. Onto this stage we can have one or several scenes attached, and onto each scene we can have a number of nodes attached to that scene. This makes up for a rather nice tree structure of our user interface. And on the lowest level, where we have these different nodes, we see these nodes as all the different graphical controls, like buttons and text fields and so on, but also some invisible parts. I say here only the visible part, but also the invisible parts, like how we lay out the user interface as well. So keep that in mind when we go further with the different parts of how to program. And a first example, and this is also always really exciting. We're going to create the normal hello world, but slightly different text, of course. We will use exact positioning because we will look at layout managers at the end of this lecture. Those of you who have tried out Swing know that layout managers can be a real pain in whatever part you like. On the other hand, if we use JavaFX, you'll see that it is quite a lot easier to make the layout work, I'd say. When we create a program in Java that is going to display a graphical user interface using JavaFX, we have a main method, of course, but the only thing the main method is actually doing is to kickstart the JavaFX parts. So it doesn't do very much, and if you look at NetBeans, for example, that they sometimes just remove the main part because it's not really where the working is. Another key difference from the previous attempts at creating user interfaces is that we now always inherit from the base class application. And since we're not using classes from somewhere else, we can go back and have normal names for all the parts. And this, ladies and gentlemen, this is the first JavaFX program. And we see a number of imports, for example, application, because that's our base class. We have group, scene, text, stage, and so on. Most of your IDs will help you in finding out the correct import to make. And then we see that the program has a class called JavaFX Lecture, and this one extends application. It has a start method, and in this start method we create the user interface. So if we skip through that and just look at the end, we will see our normal main method, and this main method actually just calls launch with a number of pushing back the arguments, and this launch is in application, and that will call the start method. So all the stuff is actually in the start method. In the start method, we see that we get a primary stage, which is of type or class stage. This stage is where we draw all our stuff, so the window itself. We create a new object of type text, which is text, and we give it a few parameters. First, the X and Y position, and then a string to display. We create a group, and we can create, when we want to do this, as I said, we want to create a tree structure. So we need to have something that attaches to other parts, and we most often create something that we call a root, which is the topmost of the different nodes. In this case, we create it as a group, and group is just a placeholder in this case. We could use pane or a number of others as well. Later on, we will see that we most often create the root as a layout manager and then attach the different parts to it. What's important is the next line, namely root get children add text, where we attach text to this group, and then we create the scene. You remember we have a scene which we look upon. We have the stage, which is topmost, and then we have the scene, which is actually what we are going to see in the theater. This scene takes the root as we just created, and it says that it should be, in this case, 500 times 100 pixels. When this scene is created, it is then attached to the primary stage, which is the stage itself, the window itself, I should say. So it sets the title and it sets the scene and then just show it. It may seem that there are many steps, but the idea is fairly simple. Create a bunch of nodes, which are text, buttons, list boxes, whatever it might be. Put this into a scene. We can create many scenes and switch between scenes in a window if we like, but we have the window in the stage. When we run this program, we get something like this. And you can just disregard the title bar if you like, because that's from my GNOME 3 desktop. If you run this on Windows, it will look with just the ordinary Windows title bar, of course. And this one merely displays the text. Any sufficiently advanced technology is indistinguishable from magic. And that is a quote from what famous science fiction writer? And we will not move past this slide before you answered that question. Who said this? No, not Asimov. This is actually Arthur C. Clarke. So you're all on the F grade right now. Here I have a slide where I try to in more detail explain exactly what's happening. We have the start method to which we send the main stage. A text object is created which holds this line of text. We have most often, as I said, a layout manager. In this case, we just have a group which holds all of this together. If we had more text, we would have attached that to the group as well. And then we have the scene, and we attach that lastly to the stage. Okay. So that's the basic idea of how JavaFX works. And we are going to see more of this as we go on. One cool thing that they added, and really not, they didn't need to do that, but they've added effects. So a bunch of effects for the fun of it, but also, of course, to make things easier to read, easier to see, easier to use, and so on. I am not really a designer, so I'll just show you an effect or two as we go along. And I do that because I want to show you the basic idea of how to use effects when we work with JavaFX. And all of these effects are classes themselves. So we create an effect object and we pass whatever node from JavaFX that we want to apply this effect onto to this object. And there are a number of them, like drop shadow, Gaussian blur, inner shadow, reflection is really nice, and so on. And this can be applied to basically any of the different nodes that are available in JavaFX. When we get to the text or to images or even buttons or text boxes or whatever you like. Just to show you an example, and from now on I will probably not show you all the code, but focus on this start method where everything is actually happening. In this case we are creating a new string with exact positioning. We set a font, which is fairly simple to do for this text, and then we create an object of type drop shadow. We call that DS, which is a new drop shadow then. We set an offset for X and Y, and that's basically how far it should go in X and Y position, and also a color for this drop shadow. And in this case we take text, set effect, and send this DS object to that. So that's a way we apply a nice effect to some object of some sort. The rest is just as before. We create a root node, which is of type group, and we attach this the text to that root, and then attach that to the scene, and we set the scene to the primary stage, and we get something like this. And it doesn't really come out quite as nicely here as it does in real life, but it's really glowing behind. And again, a famous quote from a science fiction writer, and this time it's yes, it's Asimov, but we were really down to that anyway. So great. And you can do a lot more, of course, with reflection, Gaussian blur, and so on, and they work exactly the same. And you can also change them, even though that takes a bit more work. However, it's also possible to work with shapes. So we don't need to have just text. We can draw shapes of any kind. And in this lecture we are only going to look at, or in this course we are only going to look at simple 2D effect shapes, because we really don't have time to look at all the things that we need to know in order to have 3D. But you can draw rather complex 2D shapes if you like by just using line, rectangle, circle, arc, and a number of other primitives that you draw on the screen. And we use positioning just like text, beginning at the upper left corner at 0, 0, and just draw our different things. These drawing shapes work basically the same. We have an X and a Y positioning, and then depending on what kind of class, what kind of shape we are going to draw, we have a number of different more parameters. And let's have an example. Again, just the start method, and we begin by creating a root, and then cockpit, which is a circle. It has an X and a Y position onto on the screen, and 50 in this case is the radius of this circle. Set stroke tells us what color we like on the outer end of a circle, and stroke width, the width of it, so in this case 10 pixels, and set fill to null, meaning that we will just have a nice outlined circle and not the filling. Line works as you would expect, namely that you have an X and a Y position, and then you have the X and Y position for where it ends, so start to end XY position. As you see, they work mainly the same. We have a polygon which has a number of points, as you see down at the bottom of the first column and the start of the second column, where we can see the number, the start coordinates of the first point, and then what coordinates it should draw a line to in all the other ones. Most of this is black, but we also have some red for the left cannon and right cannon. And at the end, we see root get children dot add all, and this add all makes it possible for us to add a great number of different objects to the to this scene. So instead of just creating a root and then add one at a time with root get children add, we can add all of them comma separated like this, which is a great way of doing it. Remember though that everything is added in this order, as you say. So if you are creating something on the screen that's depending on an order, you need to add them in that order as well. And now I've given you some time, so I'm certain that you've drawn this in your heads, and you see this picture. It's a TIE fighter from Star Wars. It says or something like that. Next lecture we will look at sound, and then perhaps we'll add that. Notice though that you cannot really animate this using a for loop and try to change the different positionings and so on, because JavaFX has just one thread as it looks right now. However, as we'll see in the next lecture, JavaFX has a really great built-in animation framework that makes it really simple for us to animate a bunch of stuff and do it really fast, hardware accelerated instead. For now, if you want this to move, you just have to move the window. It took me a while to draw this, so you'll have to look at it while I take some water. Okay, drawing is one thing, putting things on the screen, but sometimes, or perhaps most of the time, we actually want to interact with the user, and then we need to respond to actions. For example, button clicks, menu selections, list box selections, radio buttons, all of that. We need to be able to do something when that happens. So an action is performed and we need to do something with it. And the way we do that in Java is through event handlers and action listeners. We listen to an event happening and we react to it. Since Java 8, this can be done with extremely little code, actually. Most of the different components or graphical components that has some action that it can respond to has this set action method. And in this we need to implement the interface method handle, which is what's supposed to happen when we, for example, press a button. And with Java 8 they introduced something called lambda and lambda expressions, and we are not going into that really in this course, but it's a cool feature, cool way of reducing the code, basically. So I'm going to show you both ways, the old Java way and the new Java way, to respond, or rather to create these set action methods that we need to do. Also notice that anything that we need to to reach inside of this method needs to be declared as final. I say this now, and I will talk about it when we see the examples where this is important. But just remember that if you want to reach something inside of this method, it needs to be final. All right, let's say we have a button. This button object is called btn. In order to attach a action to this one, we just create like this button.setOnAction, which is the method we want to implement. And in pre-Java 8, we create an anonymous inner class or object, new event handler, action event, like this. And inside of that, we implement the handle method. And in this case, we just print out hello world. So it doesn't do anything more than just print out hello world. However, using Lambda, and I won't go into the details, but using Lambda, we can reduce the amount of code to something like the second attempt, namely setOnAction, and in parentheses then event, or just E if we like, or we can say action event if we like as well. And then this little arrow symbol. This little arrow symbol, all of this is possible because using Lambda, it knows that there's only one thing that we can implement. In this case, the handle. It's the only thing that we can implement inside of this onAction method. So why have all of this other code? We don't want that. So in Lambda 8 we can do that. And you'll see me using both ways of doing this throughout the lecture, and that's just because I want you to pay attention to it. Either of these ways are okay in order to create these actions. We can create a button like this, just as we've seen with text. Button, the button, new button, and then change text or whatever we like in as a string. And then on action event, which means that we are in this case using the Lambda way of doing it. And in this case we switch between shine on your crazy diamond and may the force be with you. Yeah, that's not to laugh at. We'll look at this complete example first. Where we create the text first, and we have some nice drop shadow, and we create the button. Notice here that when we create the text let's see, when we create the text, and I can't see both things over here, we need to put it as final. And that's because down here in the action, we are going to use and reach this. Now, why do we do that? Well, for JavaFX to work, it needs to know that the objects that are the nodes are the same or are created all the time. And final, in this case, means, of course, that the text, which is the object, will stay the same. It's the same object. When we, down here, change the text, we merely change the content of the object, but we do not change the object itself. It's still pointing to the same space in memory. However, the text that is shown is different. And this is something that we need to do. Sorry, I forgot this. We'll go back to these last parts in just a slide or two. But remember, if we want to reach code inside of an action, we need to declare it as final. And then it looks like this. when we press the button, it will go between May the Force Be With You and Shine On You Crazy Diamond. And Shine On You Crazy Diamond is a song by which famous... Yes? Yes, it's Pink Floyd. You're up for an A. No, not really. Do I have to ask May the Force Be With You? No, great. And you're down on an X. Yeah. But fairly simple. Create this set on action where we either through a anonymous inner class create the handle interface, or using lambda and just the arrow symbol. Okay, layouts then. One thing that Java has always struggled with is that it is fairly complicated to lay out stuff in a graphical user interface. The problem isn't so much I mean, you can always put it with exact positioning if you like. The problem is that when you have different screen sizes, different operating systems, and so on, things tend to look a little, yeah. So they invented Layout Manager, or no, they didn't invent it, but they created layout managers for Java early on. And this means that instead of exact positioning, we apply a way to lay out the different things on the screen or on the window. And this makes it possible for us to keep the relative positioning between the different components on the screen intact. So it makes it easy for us to, for example, say that, well, this editor part in the middle should actually stretch when I stretch, but the buttons up here should remain the same. And this is my personal experience, been fairly complicated in Swing to get really right. The good news is in JavaFX it's much easier. And we have a number of different panes, as they are called, in JavaFX, each of which has a different way of layouting the different components inside of it. And you can also use a layout inside of a layout. So you can use a border pane, and in the top part of this border pane you can have a H box, for example, and in the center of the border pane you can set a stack pane or whatever you like. So you can mix and match and really get some nice layouts that work really well. And as I said, there are in total 8 of these different layout managers or panes, with border pane being that we define the borders and a center. H-box, V-box, I'll talk more about in just a second because they are really flexible and nice. Stack pane puts stuff on top. Grid pane creates a grid. Flow pane creates a flow when you change the size and so on of the window. Tile pane, anchor pane, there are loads of them. Try them out, work with them. My 2 favorites, and one of the reasons why I was really excited when I started using JavaFX from the beginning, was actually H-box and V-box. And they're actually short for vertical box and horizontal box. So it takes whatever we have inside of these boxes and it arranges them either vertically or horizontal. And by putting these inside of each other, my experience again is that I've been able to create almost any kind of user interface that I like, and it works really nice. And there are also 2 methods for these: the set padding and set spacing. And these methods are used in order to define the space around or inside the layout manager. Set padding for everything around the layout box itself. So how far spaced between different layout managers should we be? And the spacing for anything inside of the box. So how far between the different components in a V box, for example. Button, text field, or whatever it might be. In order to make this, because they different graphical components have different behavior when it comes to stretching. Some of them want to stretch, and some of them, well, not so much. And sometimes you like to define a size for a button, for example, and you do that with set pref size, the preferred size of a specific component, for example, a button, to make it look exactly the same size, even if you adjust the space or the size, sorry, of the window. And this is one of my good examples, so to say. This is whenever I'm testing something, a new framework for creating graphical user interfaces, be it on desktop or on web or whatever, I always try to create this example. To have two text boxes, input boxes, and between them a button, and I want to move whatever text I have on the left side to the right side. It doesn't look like rocket science, but believe me, sometimes it's really difficult. But I made it in JavaFX, so I'm happy. What I wanted to show here also is that by using pref size, set pref size, we let the size of the text input boxes and the button be exactly the same when we resize the window. Otherwise, they would have changed in size. Now, how to program this then? Well, something like this. I call this class box layout, and it extends application as before. It has a start method. I create a text field, which I call left, and I set the preferred size to 100 by 20, like this. And notice that when I create both left and then right text field, I set them as final because I want to reach out for the content of them. I will not change the object itself, but I will reach the content of it. Then I create a button with some text and a preferred size for that one as well, and then the on action as we've seen before. And in this case, it merely takes whatever is on the left side and set that as text on the right side. The interesting thing comes after that, namely that we introduce this H box. And as I said earlier on, we most often have a layout manager as the root node of all our different nodes in each scene. And we do this here. So we create the root node as an H box. We set some padding, so around the layout box. And we use a class called insets for this. And then we have a spacing between the different things inside of the box. And that's all that there is to it. It takes care of horizontally laying out our different components. In this case, these three different components: text field, button, text field. And as we see in the root getChildren.addAll, I add them in that order. So left, button, right. And then we get that nice looking user interface that we saw before. Cool, yeah? The next lecture we are going to have on JavaFX is going to go through a number of different components and how they work. And you'll see that they work mainly the same. And we've now seen the basics of it, namely how to create and put different components onto a window, and then also to attach a simple action to, for example, a button. However, in JavaFX they also introduced something that they call property binding. And the idea here is that for a lot of stuff we actually have something that one component is interested in from another component. So instead of manually saying that, well, when I do this in this one, I'll call this one to do this piece of work. For example, if we draw a slider back and forth like this. So they have all JavaFX controls then have these properties, and it's possible using binding then to bind from one control to another control so that they listen automatically on changes on this specific property. So instead of explicitly set an event handler for an event, you add a listener to a property. And they have loads of these properties. All controls have loads of them. And we'll start by seeing a really simple, or also called manual binding for this. Binding stuff. We have a slider and we have some text. The first 3 lines are just as we've seen before. We create a slider. We haven't seen a slider before, but it's just a GUI element or control. So just put it there. And with text, we've add text, and we've also set font before. So we do this in this example. And the next 2 lines are the important. The slider value property add listener means that the slider should listen to the property that's available in the text. So it listens to whenever we change the slider, we will emit a signal to the text that it should change the size of the text. And then we have some nice layouting as well. And we get something like this. And you can, I cannot show you now, but if you draw the slide back and forth, instead of calling an action, which we could do, we have now connected a property to another property really within with JavaFX. So it automatically listens to this emission of change. And proper binding means that we use a bind method and say this object should listen to this in this object. And we do that using bind or bind bidirectional, which means that it goes both ways. And we can also unbind, of course, if we like. And just to show you an example, here we have, and this is a nonsense example because we will never need this. But whatever I write in the upper one, so over here, yeah, I write something and directly it will be printed down here. And I'm doing this bidirectionally, so when I type something down, down here, it will also appear in the upper box. And how to do that easily then? Well, just these few lines of code. We create 2 text boxes, and as you see on the 4th line, first text dot text property, so the text property of the first one should bind bidirectionally to the text property of the second one. You will not need to do this, but just to show you that binding actually makes it easier for you to bind stuff that's very often bound together in a simple way. All right. binding can sometimes be a headache, but I wanted to show you it because it's a nice feature of JavaFX. And since the air is almost out, I will end this by pointing you to a few places where you can find out more. The next lecture is, of course, a great way to know more about JavaFX, so don't miss that one. But there's also plenty of things that we can look at by going to different web pages and read up on stuff. One of the great ways of actually looking at what's possible using JavaFX is to go to the URL at the end here, where we can look at the JavaFX Ensemble application, which looks something like this, where it's possible for us to go through all the different things that are available, from buttons to these advanced bubble chart, whatever that might be, say. All of this is available in this application just for show, so you can get a feel of what kind of cool stuff you can actually do. And I've also, in the slides here, outlined a few nice places to go to if you want to learn more about JavaFX. Again, I will give you some more details in the next lecture, but if you're like me and you say, oh, this was so very sexy, these are the places you should go to. The official documentation, of course, but there are a few tutorials that are really great as well. There's some written literature. In the beginning there weren't very much, but today I can really recommend these 3 books. You don't have to buy any books to finish this course, but JavaFX is really awesome, so you should. And these are good books. The 3 first ones here, they are really general. And then we also have the beginning JavaFX 8 games development, which looks a lot more at how to create games. And it's really great for finding out exactly how to work with animation. I will show you some of that next time, but not as much as in this book. If you want to buy a book or two, see to that they are at least about JavaFX 2, even better JavaFX 8, or if it doesn't say number at all. There are still some pre-Java books out there, so be careful. Read up so that you know that it is about JavaFX with Java and not with scripting. There's some third-party add-ons. And there's a summary. The Controls FX is the most mature one, as I spoke of in the beginning. And that was the way that we used to work with dialog boxes before they actually implemented that in JavaFX. JavaFX Extras, more exotic but quite useful and fun controls as well. Next time I'll show you a bit more about theming. I haven't said very much about that here, but actually, as I said, one of the problems with Swing was that it was really hard to create new and good-looking user interfaces that didn't suck, basically. In JavaFX, however, they have something that looks very much like CSS in web development. They have some extras into that, but it's a lot easier to make really good looking user interfaces. And there are some today that you can download as a CSS file, and you add it to the project, and your application will look like Windows Metro, whatever version, or Apple Aqua, so that it fits into whatever platform you're using. Here's something about how you can add Controls FX, either using Maven or downloading the jar file and add it. really cool stuff. I just want to say that it is also translated into 17 languages, including Swedish, by. Okay. That was not a commercial break at all. And here's just a short example of the rating component that's available in Controls-FX. And it's really, in this case, it's really as simple as just adding rating as an object in your application, and it works. You can send dozens of different parameters to it as well. As default, it has a 5-star rating, but you can put it to 3 or to 10 or whatever you like. You can have whole stars or half stars and so on. When it comes to Pink Floyd's The Endless River, it's top-notch anyway, so just use that. All right then, this has been an introduction to JavaFX. We will show you a lot more in the next lecture, but thank you very much for today. Thank you.